last dimension. And slabs are the easiest things to find the volumes of. Just multiply the three dimensions together. And then finally, horizontal strips are indexed by y values. Different y values give me different strips. What's the y value for the very bottom strip? Zero. And the y value for the top strip? 1. So this integral is going to give you that volume. That was kind of a long question. First thing that we did was we talked about the area between two curves. I feel good about doing the horizontal and the vertical strips is the first question today. Second thing we talked about was how to find volumes if you rotate it around a horizontal and a vertical line. And the two strategies you had were washers or discs, the other one shells. And washers and shells with horizontal and vertical lines. And then after that, we talked about work. So, if I have a heavy weight and lift it up by some distance, I did some work. And we had 3 types of work problems. One of them? So remember the 3 basic types of work problems? So one of them was you have a chain or a rope hanging off the side of a building and you wanted to bring it up to the top. What was the second thing? You had a tank full of water and you wanted to move all that water out of the tank. And you remember the third one? A spring, exactly. You have a spring, it's you wanted to compress it by a certain amount, that would take some work, is how much work to compress. And in the questions here, I have all 3 of those types. Grab that. I don't know why I started with the spring one. So the idea with the spring, first of all, is if I want to keep a spring stretched or compressed, it's going to take a certain amount of force. And if you remember the equation that relates how much force I need to keep it stretched to the distance I want to stretch it by. So we call that Hooke's law. For springs, it's the equation that governs how a spring behaves is F equals kx. And what I have is before I've done any stretching, it's the spring is at 20 centimeters. And remember, we get to, that's just the wall I'm attached to, is we could make the x equals 0 correspond here. But we get to set up whatever coordinate system we want. And I think the best one is going to measure how far we're stretched from the natural length. So I'm going to let x equals 0 in my coordinate system correspond to the spring just hanging out at its natural 20 centimeter. And then, here's what happened. And somebody decided to stretch the spring. Now we're going to make it longer. It is now, it's 30 centimeters. And just to hold it here, there's a force. And the force is relative to our coordinate system. Remember, x equals 0 is here. And how far are we stretched beyond its natural length? this is an extra 10 centimeters. So a spring is completely described by Hooke's law. The force is K times the displacement. And in this example, 40 newtons is K times 10 centimeters. Implies K. So for this spring, F equals 4x. If you want to keep it stretched by 2 centimeters, how much force do you need? 8 newtons. So that's the whole idea. 10 centimeters is 40 newtons. And now what's going to happen is somebody is going to pull it even further.